Hello everyone, welcome back. Today I want to give you an extra content about short circuit test for 3-level system. So short circuit is SC. And this is also the last part of this course. And SC test, from the name you can realize that we will test one of the worst case during our operation. This test is quite important to evaluate if our system can be turned off safely when SC appears to protect our complete system and also prevent further damage to other components and even to our human body. Before the test, I must warn you that short circuit test is dangerous accompanied with possible explosion. In this course, I only give you the theory part, only theory. So if you want to do this test, please be careful and ask your tutor or colleagues for the necessary support. So safety is always the most important thing for us. Keep it in mind, please. First part, let us take a look how to do the SC test. So go to this slide, look into this topology. As we can see that the 0 point here is connected to our AC bus. So you can see this green line. We use a short cable or a copper to generate such connection, which means that we create a short circuit condition manually here. Under this situation, we test the dynamic parameters of T1. The recorded data is also similar to double pulse test, but the difference here is that we give now only a single pulse to T1, not double pulse signal, because for SC test, a single pulse is totally enough. Also, it is very important for our safety. In actual application, the control unit from customer side will block the signal immediately when SC is detected. But normally in the lab, when we are doing the SC test, we don't have this kind of control unit to block the wave. So if there is double pulse, you send the double pulse to T1, it may causes the second short circuit after the first pulse and then damage the module. Although our GDU will block the wave, therefore from safety aspect, please remember only single pulse signal during SC test. It's very important. Okay, now let us back to the contents. There is another point I want to talk. When we turn off T1, you will find that a freewheeling path is necessary for current. If there is no path after the off of T1, then on the terminal of this copper, this two side, an extreme high voltage will be generated and damage our module. The reason behind it is that there must be an inductance on the copper or short cable due to their physical structure and characteristics. The difference is how much is this inductance, but there must be straight inductance on it. And this inductance can generate voltage by equation. I write the equation here. Voltage is equal inductance times di dt. So if current disappears in a short time, which means there is no freewheeling path, then extreme high di dt can be created and causes this high voltage on the terminal of our copper or short cable. Therefore, we must provide a freewheeling path which we can find that T2 now is kept on during the test. So you can see after the off of T1, the current can flow through our T2. It's very important. Please keep this point in mind. During the test, we need firstly increase the voltage to a certain level. Remember, don't start from a low voltage for IGBT, like you start from 100 watt or 12 watt for a 1700 watt module. Because of IGBT's own characteristics, the SC on the low voltage can lead to a severe oscillation and even damage our module. Therefore, please start from a relative high voltage level like 500 watt or 600. However, there is also different. However, if you test SiC silicon combined module, then you can start from even 20 or 15 watt. It's okay. It's fine. So more details will be included in the future course for SC test. But here, please remember this point. There is difference between IGBT and SiC. Here, I just measured and let you have an impact of this point. Okay, after the voltage increasing, give a single pulse to T1, we need to firstly record VGE, the gate emitter voltage, collector emitter voltage, VCE, and the short circuit current waveforms. It is similar to the double pulse test. Why we need to observe VGE? The most important reason is that under SC condition, short circuit condition, the gate voltage can be much higher than the rated value. For example, the voltage can go up to even 13 volt when your rated value is 15. What will happen then? The first risk is the gate voltage will damage the module. And the second risk is higher gate voltage means longer turn-off time, and then the chip in the module that need to effort such high current for longer time, which means which will lead to a greater heat generation. And in the worst case, if the heat exceeds the threshold of module, then the module can be broke. So please remember this point. And the next parameter is VCE. Because of the high current during the test, a high voltage peak can be generated and added on the VCE, which will cause a voltage peak like in normal double pulse test. I hope you still remember that in the second pulse you will see that when we turn off the module, there will be a voltage peak. I hope you still remember this. And this peak shouldn't exceed the threshold. If it does, then we need to adjust our protection parameters to suppress this peak during the test. The next parameter is collector current IC. So for IGBT, this current can be normally 5 times higher than rated value or even 10 times. And this is an important parameter to evaluate the heat generation during the SC test. And here, by the way, when you test SiC module, the current has no limit. So the increase of current has no limit. So it depends only on when you turn off that module. If you didn't turn off it, the current can increase continuously until the module broke. Okay, this is what we need to pay attention to the SC test. Now we can go to next slide. We will test T2 now. Like the complete process in last slide, a single pulse is given to T2. But this time we don't need to turn on other IGBT because as you can see here, a freewheeling path is through T4 directly. And also we can test T3 in this way, only single pulse to T3 and keep other IGBT off. In the end, T4 is tested. This time we need to keep T3 always be on to provide freewheeling path, and the other process is same like when we test T1, so the process is quite similar. Okay, this is general introduction how we make the short circuit in 3-level system. I hope you have already a general impact on it. Here, I want to give you some experiences from our daily work. The first point is that please remember that before you start increasing the DC voltage, check your connection first. Make sure that all cables are connected correctly, no short circuit, no fake connection, no coupling between high voltage and low voltage cable. Then we must test our system on the low voltage first. Drive the GDU, give a double or single pulse to check if GDU works, if the waveform is correct. And for the SC test, if you complete the building of platform, remember, check if short circuit protection runs. It is very important to do that step. Otherwise, you will see the explosion if your short circuit protection didn't work as usual. Another suggestion is that never touch your platform before you ensure that the system has been completely discharged, especially in short circuit test. I also mentioned this point in the double pulse test. It is quite dangerous if you touch the platform by hand without any safety check, so please remember. Okay, this is all content for this lecture. Please don't forget to follow us if you like our video. See you in our next course. Bye.